Good day everyone, I am Sheena Ibali from BE Ed 3C. Today we're going to exploring the core of math education, a midterm recap. And these are the major topics that we're going to talk about now: the concept framework of mathematics education, the rules of mathematics education, the 7 learning principles, the 9 teaching principles, the vision of fully competent mathematics teacher, and the last levels of teachers' growth and development. So in conceptual framework of mathematics education, we have twin goals: the critical thinking and problem solving. So here it is not just about memorizing facts and crunching numbers. It's about developing two powerful skills, the critical thinking. So here it talk about thinking deeply, analyzing information, and making logical connections. So it's about asking assumption, evaluating evidence, and forming sound judgments. In math problems, you often require to break down, identify patterns, and use logic to find solutions. So here you are trains your brain to think critically and all areas of life. The second one is the problem solving. That is the ability to identify a problem, figure out how to approach it, and find the best solutions. So it involves creativity, planning, and evaluating different approaches. So the 5 areas of mathematics, we have the number and number sense, measurement, geometry, patterns and algebra, probability and statistics. So the first one is the number and number sense. So it is the understanding the meaning of numbers, their relationships, and how they work. So this includes counting, place value, comparing numbers, and performing basic operations such as addition, subtraction, multiplication, and division. For example, knowing the 100 is 10 times bigger than 10, or understanding how to estimate the cost of groceries. So the second one is the measurement. So focus learning about units of measurements like length, weight, volume, time, and how to use tools to measure accurately. So that includes understanding how to convert between different units. For example, the length of a room in meters, or calculating how much it takes certain distance. So the third one, geometry. So exploring the properties of shapes and figures in 2 and 3 dimensions. This includes understanding things like angles, lines, polygons, and fourth is the pattern and algebra. So it is recognizing and describing patterns using variables to represent unknown quantities and solving equations. This involves understanding the relationship between different quantities. For example, identifying the pattern in a sequence of numbers, solving for x in an equation, or understanding how graphs represent relationships. The last one is the probability and statistics. It is the understanding the concept of chance and data analysis. This includes calculating probabilities, collecting and organizing data, and interpreting graphs and charts. So this time we are going to talk about the high-level skills and processes and the importance of each skill. The first one is the knowing and understanding. So this is the foundation of everything else. Without a solid understanding of basic concepts and facts, you can't build upon them. It's like trying to build a house without bricks. For example, knowing the multiplication tables is essential for solving more complex equations. The second one is estimating, computing, and solving. So this is where you put your knowledge into practice. You learn how to use mathematical procedures and strategies to tackle problems. For example, estimating the cost of a shopping trip, calculating the area of a room, and solving a word problem. So the third one is visualizing and modeling. Many people learn best visually. Representing math concepts using diagrams, graphs, or physical models can make them easier to understand. For example, drawing a diagram to understand the concept of perimeter, or using blocks to build a model of a three-dimensional shapes. The fourth one is representing and communicating. So it is about being able to explain your mathematical thinking clearly and concisely is essential. This involves using different forms of representation like writing, drawing, or using symbols. So the fifth one is the conjecturing, reasoning, and proving and decision making. This is where you develop critical thinking skills. You learn how to formulate hypotheses, test them, and draw logical conclusions. For example, making a conjecture pattern, listing it with example, and prove it with logical argument. Well, the last one is applying and connecting. So this is where you see the real world value of math. You learn to apply your skills to solve problems in different contexts and connect them to other subjects. For example, using to calculate a budget, understand scientific data. So these skill set work together to develop a strong foundation in mathematics, enabling you to solve problems effectively, think critically, and understand the world around you. So let's move on now to the values and attitudes in mathematics. The first one is the accuracy. Math demands precision. Accuracy ensures that solutions are correct and reliable. It also helps students to develop a sense of responsibility for their work. So to foster this, encourage students to double check their calculation, use appropriate tools, and be meticulous in their work. So you should provide clear expectation and feedback on accuracy. The second one is the creativity. So math isn't just about following rules. Creativity allows students to explore different approaches, think outside the box, and find innovative solutions. So to foster this, you should present open-ended problems, encourage brainstorming, and allow students to experiment with different methods to celebrate unique and effective solutions. So the third one is objectivity. So math is based on logic and evidence. Objectivity helps students avoid biases and make decisions based on facts. So to foster this, you should encourage students to analyze information critically, consider multiple perspectives, and support their conclusion with evidence. The fourth one is the perseverance. So math can be challenging. Perseverance helps students develop resilience and ability to keep trying even when they face difficulties. To foster this, you should break down complex problems into smaller steps, provide encouragement and supports, and celebrate progress even when the final solution isn't reached immediately. The last one is the productivity. So this involves using time effectively, organizing work efficiently, and completing tasks on time. So to foster this, teach time management strategies, encourage planning and organization, and provide opportunities for students to practice working independently and collaboratively. By fostering these values, we can help students not only become proficient in math, but also develop important life skills that will benefit them in all areas of their lives. They learn to think critically, solve problems creatively, and approach challenges with a positive and productive mindset. This time, let's move on to appropriate tools for mathematics instructions. And we have manipulative objects, measuring devices, calculators and computers, smartphones and tablet, and the last is internet. So we have the first one, manipulative objects. So these are the blocks, counters, diagrams, or geoboards. So these objects or abstract concepts gives more concrete and understandable. So students can physically manipulate these objects to explore patterns, shapes, and quantities, leading to deeper understanding. Next, we have measuring devices. Examples, rulers, measuring tapes, scales, thermometers. And this helps students to learn more about measuring units, develop accuracy, and connect math to real-world applications. Next, we have calculators and computers. These are graphing calculators, spreadsheets, and online math tools. And these tools help students to perform complex calculation quickly and visualize mathematical concepts. Next, we have smartphones and tablets. So these examples are math apps, educational games, and online videos. And this offers interactive learning experiences, personalized instructions, and access to a wealth of mathematical resources to students. And the last one, we have internet, which provides a vast amount of information, practice problems, and interaction tools. This allows students to collaborate with others and access expert resources. Next, we have context in mathematics learning. First is belief. So students' belief about math can significantly influence their motivation, efforts, and performance. So if they believe that math is difficult or boring, they're less likely to engage in success. So for example, a student who believes math is only for smart people, so might be less likely to ask questions or seek help when they struggles. The second one, we have environment. So the classroom environment, including the teacher's attitude, the physically space, and the interaction between students can greatly impact learning. Positive, supportive environment encourages engagement and risk-taking. For example, a classroom where students feel comfortable asking questions and sharing their ideas is more likely to foster love of learning. Third is language. So the language plays a crucial role in understanding mathematical concepts. So students need to be able to understand and use mathematical vocabulary and symbols effectively. For example, a student who is unfamiliar with the word perimeter might struggle to understand a problem involving calculating the distance on around a shape. Fourth one is culture. So culture shapes students' perspective, values, and approaches to learning. For example, students from different culture might have different ways of presenting numbers or solving problems. The fifth one, we have prior knowledge. So students' prior knowledge and experiences influence their ability to build new understanding. Connection to previous learning can make new concept more accessible. For example, a student who has a strong foundation in basic arithmetic will find it easier to learn algebra. And the last one, we have experiences. So real-world experiences can make math more relevant and engaging. For example, a student who enjoys cooking might be more interested in learning about ratios and proportion when they see how they are used in recipes. Now let's move on to learning theories. First, we have experiential and situated learning. So learning happens best through active engagement and real-world connections. Students learn by doing experiences and applying knowledge in context. So for example, math, real-world problems, solve problems related to budgeting, cooking, and measuring or designing. This reflective learning become better learners by reflecting on their thinking process. They analyze their things, weakness, and strategies. So in math self-assessment, have students evaluate their own understanding of concepts and identify areas needing improvement. Third is constructivism. Students actively build their own understanding based on prior knowledge and experiences, so they don't just passively receive information. For example, connect new concepts to what students already know, asking them to share their experiences and make connections. The fourth theory is cooperative learning. So students learn effectively by working together in groups, supporting each other, and develop social skills. So you can involve jigsaw activities in your discussion or at the end of the lessons. The last one, we have the discovery and inquiry-based learning. So students become active investigators who ask questions, explore concept, and discover knowledge through experimentation and problem solving. Now let's move on to teaching principles. In principle 1, it's talk about math is more than problem solving. So you should connect it with another context. In principle 2, you should be mindful where the students live so that you will know what words you will integrate. Principle 3, students must be active, so there is active participation. Principle 2, it's talk about that learning takes time. And principle 5, you must be sensitive, you must be considerate with other genders or religions or cultures. And principle 6, assessment must be integral part of mathematics instructions since it is guide teachers and students to know what are the strengths and weaknesses or what are the needs to improve. And principle 7, the teacher should be adaptable. And principle 8, so you must know as a teacher the technology and how it is used to know how to use it in your discussion. And principle 9, the teacher should not stop learning. So meaning teaching is continuous learning. So next is the learning principles. So in principle 1, it's talk about it is beyond computation. And the principle 2, it's talk about how important the physical environment or physical settings in learning mathematics. And principle 3, it's talk about the active participation of these students. And principle 4, it's talk about there are lots of varieties tools for learning mathematics. And principle 5, it's talk about the value of what and how students learn or feel to learn mathematics. So you should be considerate. And principle 6, so the teacher unbelief about mathematics affect their learning. So as a teacher, you must know the cultural backgrounds of the students or the biography of the students. And principle 7, it's talk about the support system of the students, which is the parents and other community to help their learning progress. This time, let's move on to the vision of fully competent mathematics teacher. So the mathematics content knowledge, so as a teacher, you should know what are the subjects, so you should be expert on that. And mathematical pedagogical knowledge, as a teacher, you know what theories you are going to implement or what are the strategies that you are going to implement. And the general pedagogical knowledge, you will know how to apply it in general or in other contexts. And classroom management skills, as a teacher, you will know how to manage the physical setting, you know how to manage the classroom. Next is mathematical disposition. It's talk about the consequences of the decision of teacher to the learning of the students. And next is the professional development. It's talk about that teacher must attend workshops or trainings or seminars. Next, we have the levels of teachers. First one is the novice. It's talk about that the teacher is just graduate in the degree and just graduate in LET. The next one is emerging. It's talk about that the teacher know the content but he didn't know what approaches he was going to implement. Third one is the accomplished. It's talk about that the teacher know how to handle the classroom environment and the students. And this teacher is know the solid foundation, meaning he know the content. And the last level of teacher is the expert. This means that the teacher is, and the last one is the expert, and these teachers know all the components. He know what are the things he will do, and he know how to handle each students in his classroom.